Hello and welcome to my final ramble for IEB May 2025 paper 1. The last question. It looks juicy and exciting. It's giving geometric I don't know. Question 13. Circles are placed next to each other indefinitely along a straight line BC so that the circles are touching each other. The radius of each circle is half the radius of the previous circle, and the radius of the largest circle is 1 meter. A is the center of the largest circle. AC is a straight line drawn through the centers of all the circles. Show that AC is 3 meters long. Right, so technically these circles never end. If you zoom in, you're just going to keep seeing more and more circles. We're told that the radius of the largest circle is 1 meter. So then the next one is going to be half. The next one is going to be quarter. So 1 meter, half a meter, quarter meter, and so it goes. And we need to show that AC is 3 meters, right? So we have 1 plus a half plus a half, because remember it's going to be 2 radii. In fact, for all of the circles henceforth it's going to be 2 radii. So plus a quarter plus a quarter plus an eighth, and so on to infinity, right? And so, I mean, we can think of this in 2 ways. We can kind of put in an invisible +1 there and then minus it at the end of our calculation, so that we are able to just make this calculation like this: 1 plus a half plus a quarter plus an eighth, and so on. And then of course remember to minus the extra one that you introduced. And then this guy over here is a nice geometric, you know, to infinity and beyond. What do we call it? Infinite sum. So that would be this is our formula. Our first term would be 1. Our r would be a half. So that would be 2 times 1 over 1 minus a half, and then remember to minus the extra one that we, so basically minus this radius because it's not part of AC. Oh, and actually, oh shucks, you know what? It's not just the one that isn't being duplicated. Also, right at the end, for, yeah, because if we suppose there's an end point somewhere and this is the starting one, this last radius won't be included in the sum. So hey, how do I account for that? I don't know if I can, because I don't know what the last term is. Is there even a concept of there being a last term? Part of me feels like, you know, if there is a last term, this will be so small that it's negligible whether to include it or not. So I'm tempted to just soldier on with plan A. Or kanjani? Yeah, hey, I think so. So I am going to go full steam ahead and just rewrite exactly what I just wrote. right? And so it goes, minus the extra 1 radius there. So then this would be 2 times 1 over 1 minus a half. Oh, right. So then we have 2. I mean, we could just put this into our calculator for pit's sake. Except our calculator is sleeping. Right. 1 over 1 minus a half. I mean, it's looking promising. So that would be equal to 3. As prophesied. Another way that we could do it is we could say 1 plus 2 times a half plus a quarter plus an eighth and so on. I mean, it's pretty much, it's the same, but you know, 1 plus, so then this would now be, the a would be a half, the r would still be a half, and if we add that up, we have 1 plus 2 times a half over 1 minus a half. So all roads leading to Rome are leading to Rome, you know what I mean? Right. Oh, my order is on its way. My order is on its way. My order is on its way. Anyway, so we have successfully shown that AC is 3 units, 3 meters. Next up, they say, calculate the area of the shaded region. How to can do it. So my immediate inclination is, you know what, I don't know what shape this is, but I do know this is a quarter circle. How do I know that? Because 10 red, so this is a 90 degree, and 10 red, this is a 90 degree as well. How do I know that this is a quarter circle? Is it a quarter circle? Or am I just lying to myself? Sorry. I know that this is a half circle. That much I know. Half, 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 and it's going to be halves until the end, whatever the end is. So let's just say, yeah, because there's gonna be a circle like this at the end. Hey, here's a drawing and me, it's just not working out. So the last circle, whatever that even means, yeah, hey, this thing is interesting because now does that mean BC, AC is a straight line draw through the centers of all the circles. So I just assumed that C is the center of the last circle, inverted commas. You know, when you talk about infinity, you can't really talk about a last anything, but I just assumed that C is the center of the last circle, but it's not, right? Because they say that BC is a straight line. So that means that actually C is this guy over here, and presumably it is where where the last circle, so the last circle would be like here, you know what I mean? So it would be the end of the last circle's diameter. So actually, like, even the whole moral dilemma I was having up here is irrelevant, because that was assuming that C would be the center of the last circle, and it's not. C is the end of the line BC. So the only radius that's not included in C is this one. So the maths matched. So never mind all the stuff I said about negligible what. I just wanted to use big English for fun. Anyway, so so my dilemma right now is, I don't know what portion of the circle this is. I want to say it's a quarter because that would make me feel good, but it's not necessarily. So the most that I have been able to come up with is that this is a 90. Oh, and then we've worked out that this is 3 meters, this AC. We know that this is 1 meter. So then I can work out the size of this angle, right? And then that will tell me what portion of the circle that is. This is why it's so important when you prepare for your maths. Just try to prepare for the whole content, because you never know when you're going to need trig. Right. Anyway, so fine. I can now work out what portion of the circle this is. So first of all, I know I can work out the area of this triangle. I can figure out the base, the length of the base using Pythag, and then I can work out these halves also to infinity, assuming that's a geometric sequence. Let's have a look. So for circle 2, the area would be pi. Okay, it would be nice to say what you're working out. The area would be pi half squared, so that would be a quarter pi. For circle 3, the area would be pi quarter squared, which would be a 16th of pi. And then for circle 4, we would have pi, and the radius is an 8th, so that would be a 64th pi. And just for good measure, we'll work out the area of circle 5. So that will be pi, the radius will be a 16th. We square that, right? So we have a 256th pi. And if we work out what is the r here, so 1 over 256 pi divided by 1, I think it's a quarter, but let's just be sure. So that's a quarter. And then we have 1 over 64 pi divided by 1 over 16. Oh, what is happening in the universe? This is what happens when you calculate without seeing what's going on. 1 over 16 pi, and that also, oh heavens, heaven bless us all. So that's also a quarter. And then let's just check the last one, divided by a quarter pi, and that's also a quarter. So the areas of the half circles form a geometric sequence where A is a quarter pi, that is the area of this half a circle, and the R is a quarter. Right, so we can work out the sum of these half circles to infinity, and then this one is a special case because it's not half a circle. So we're going to need some special maths to figure out that area. Right, so I'm just going to highlight here that each time we are timesing by a quarter. And in actual fact, we weren't working out the area of the full circle, we're just working out the area of half the circle. Okay, right, so it's really good that they nudged us to work out. Yours is not going to work in my favor. It's really good that they nudged us to work out this, because without that, the gal was going to be stuck. Yeah, I'm going to put this here, right? Okay. My delivery is around the corner. Oh no, oh no, oh no. Okay, I need to wrap this up. Okay, so the half circles will be given by A, which is a quarter pi over 1 minus r. So that will be, oh no, the pressure is too much. Oh, and now I'm doing nonsense. A quarter pi divided by 3/4. So that will be pi over 3. Okay, and then, oh, I'm not going to finish this in time. Oh, I'm going to need to stitch the two. Anyway, okay, so random pause. All right, resuming at a calmer pace because delivery has been collected. Anyway, so we were calculating the first component of our sum, which is pretty much the sum of these half circles to infinity, etc., etc., right? So we said that that's a geometric sequence, geometric series, where the area of the first half circle is a quarter pi, and the common ratio is a quarter, my gosh. So the areas of the circles shrink by a factor of a quarter. So then this is the calculation using sum to infinity, and we frantically got an answer of pi over 3. So that is the sum of these half circles. Okay, next up we want to work out the area of this random piece of circle here. So I'm going to take this and shrink it all up, put it in a corner. Okay, right, maybe I'll do this in a different color. So for that, we're going to use the fact that first of all, AB is perpendicular to BC because of the tangent BC being perpendicular to the radius AB. And then we know that AB is equal to 1 because it's a radius. And we also showed that AC is 3 meters long. So then to find this angle, we'll use, what's this, adjacent and hypotenuse, so we'll use cos. So cos of BAC is given by 1 over 3. So then BAC will be shift cos, well, inverse of cos of a third so that will be 70,5 blah 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 degrees. So now that allows us to, I'm just going to shrink this so that all of this is on one page. So what that allows us to do is, okay, I want to say many things at once. So I just want to fill in where that fits into the picture. So this is 70,5 whatever degrees, this angle over here, right? So now we can then say this piece of the circle is 70.5 degrees out of 360 degrees of the full circle. So the area of this little sector here will be given by 70.5, what degrees out of 360 degrees times the area of the full circle, which would just be pi times 1 squared. So let's work that out. So this is answer divided by 360 times pi times 1 squared is just pi. So this is 0.615 blah 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 square meters. So I'm going to store that answer. Right. So we now have two pieces. We've got the area of this thing, which is that. Okay, and then we've got the area of the half circles. Now we can work out the area of the triangle and then minus these pieces so that we get the area of the shaded part. So area, okay, in keeping with Rainbow Nation, area of triangle ABC will be okay, I'm just going to use trig. So I'm going A because I should be working out the base. I think I'm just going to work out the base because now I've lost my angle already. Okay, so we know that BC squared is equal to 3 squared minus 1 squared, right? Because Pythag said so. So that will be 9 minus 1, which is 8. So BC will be the square root of 8, or 2 root 2, if you simplify that. So then the area of triangle ABC will be half base, which is the BC, which is 2 root 2, times the perpendicular height, the AB, right? So then that's just root 2 square meters. Okay, so now let's put the whole pi together. Wow, and there is pi actually in the mix. So we're going to say the area of the triangle minus this area minus the sum of all of these half circles. So area of shaded parts will be given by root 2 minus the 0.615 blah 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 minus the pi over 3. That awkward moment when this answer turns out to be negative, that will just be so painful. Right, so we have that minus, I think I stored you in here, and then this one is shift pi over 3. It turned out to be negative. Your way. That ain't right. That is not right. The answer should not be negative. So let's have a look-see at where we've gone wrong. Wrong, 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 wrong. Wrong, 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 wrong. Okay, so we know that the radius is halving. Okay, first of all, we know that AC is 3 meters. The question paper said so. We might not trust our own maths, but the question paper said so. Right, second of all, we know that the radius is halving each time. and the radius of the largest circle is 1, so the radius here is a half, a quarter, an eighth, a 16th, and so on. So we then saw that the radiuses, the areas of these half circles form a geometric sequence. Oh, but I didn't have. I worked out the areas of the circles, not the semicircles. This is what happens when you rush. This is what happens when you rush. This is what happens when you rush. So technically I think I should just be able to halve this, but I think that for the sake of OCD, I'm just going to start from scratch. You know when you get excited that you got the thing, but then you don't finish well. It's painful, man. It's painful. Right. So half of circle 2, the area is half of pi half squared, which ends up being an eighth of pi. Half of circle 3, we have a is equal to half of pi quarter squared. So quarter squared is a 16th, and then half of that is a 32th. Right, half of circle 4 will be half of pi, and then that radius is an eighth. So then you have a 64th, and half of that is a 28th. Right, and if we're to look here, to go from there to there, you times by a quarter. To go from there to there, I'm pretty sure you're timesing by a quarter as well. Yeah. So we do still have a geometric sequence. So the area of the half circles will be given by the sum to infinity, where a is an eighth pi, the r is a quarter. So let's calculate this now. So we have an eighth of pi divided by 1 minus a quarter, so that is pi over 6. So as initially suspected, it's just half of that previous number we had worked out. So the area of the half circles is actually pi over 6, not pi over 3. So returning swiftly to our momentous calculation, we have root 2 minus the answer that I stored. Oh, here one. And minus pi over 6. Hey, guys. Pi over 6. Oh. So that is about 0.28 square meters. Right. Let's have a look at what the memo thinks of our valiant efforts. What is happening? 1 plus 1 plus half plus quarter. Oh, I see. So they're saying 1 plus 1, this diameter, plus a half. Okay, they just combined these, which is clever. Whatever. So we both arrive at 3. Good. Then the next one, we did use some Pythag, we did use some trigonometry, and yeah, I don't see anything different in how they did their solution. So yeah, final answer 0.28 square meters. And that is that for May 2025 IEB paper 1. Hope you come along for the paper 2 journey as well. Until then,